AI Ethics with Matthew Renze.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results through its ClearMeasure way for effective software teams. Quick announcement, my architect forums are going strong. You can sign up for the next session right now, and the link is in the show notes. If you lead a software team and are looking to collaborate with peer architect leaders, then just go ahead and sign up at the link in the show notes. And for those of you looking for my Programming with Palermo video podcast, you can just search for it in any of the podcast directories or on YouTube, and you'll be able to find it. Now, the guest today on the show, the returning guest back from episode 220, is Matthew Renze. And he is a data scientist, consultant, author, and public speaker. He's the founder of Renze Consulting, an AI consulting company that has trained over 500,000 software developers and AI professionals. His clients range from small tech startups to Fortune 500 companies, and he's also the president of Serenze Global, a 501c3 nonprofit organization dedicated to improving access to technology education for underrepresented individuals by empowering the next generation of tech community leaders. Matthew is currently working on his master's degree in artificial intelligence with a data science specialization at Johns Hopkins University. And he currently has double degrees in computer science and philosophy with a minor in economics from Iowa State University. He is a Microsoft Most Valuable Professional in artificial intelligence. He's also an ASPinsider and an author for Pluralsight, Udemy, and Skillshare. And his interests include AI, ML, data science, mindfulness, technology education, and tech community leadership. Matthew, welcome back to the show. How are you, sir?
Thank you for having me back.
Oh, my pleasure. My pleasure. We'll make sure to include a link to your last episode in the show notes. And I think we were talking about developing your AI strategy back then. But I want to get into AI ethics. But before we get into that, let's just back up a little bit for people who haven't seen you on Pluralsight or all the different places. Kind of backtrack and review for us. What got you in to artificial intelligence, and what was the path like from programming and then data scientist, and now you're in a master's program for AI? What were those triggers that set you down that path?
Well, I think I was always interested in artificial intelligence, at least from when I was a little kid. And I got into software development from college, and I kind of reached the peak of my career as a software developer, I felt. Like I couldn't go any further unless I went back to college and got a degree in computer science. I was working on the most difficult things I could at the current level I was at. And so I went back to college. I got the double degrees in computer science and philosophy with that minor in economics with a focus on artificial intelligence and machine learning. And what I learned from the AI and machine learning parts of my computer science degree were the most interesting and most valuable to the stuff I wanted to do. So right around that time, the word data science started popping up. And it sounded exactly like what I had already been doing. I'd been working as a software developer on these big data projects before we had the term big data. Mm-hmm. And I was doing a lot of data analysis and a lot of data processing, the same kind of things that we'd be doing as a data scientist. And then I got into machine learning. And once I learned how to use these tools, I realized, okay, this complements my data science skills quite well. So I continued, I rebranded as a data scientist for literally the next decade after a decade of being a software developer. And then now I'm to the point where I'm like, okay, I'm doing so much with artificial intelligence and there's so much demand for AI. I think it's time to rebrand myself from a data science consultant to an AI consultant. But before I do that, I want to make sure that there are no blind spots in my education and my skills. So I went back to college again to get a master's degree in artificial intelligence. And through this master's degree, I'm essentially learning everything that I might not have learned from all of the on-the-job stuff. Because much like statistics, you can go pretty far without statistics background, but you will eventually shoot yourself in the foot, and usually in a really bad way. So I wanted to make sure I don't have any blind spots. And this master's degree gives me the confidence, okay, I can go out here, rebrand it as an AI consultant, and I know what I'm talking about. No one will question that. At least I hope not.
Gotcha. And there's so much talk going around generative AI and then narrow AI, and there's so many buzzwords going around. And just a few short years ago at the Microsoft conferences, Ignite and Build, they were labeling so many things machine learning. Whereas now a lot of people are talking about like the state of the art of machine learning as AI again. But so can you demystify what the buzzwords are and why we call everything AI, and how if you call everything a term, it ceases to be as meaningful? Help demystify. What exactly are we talking about here?
So it is a great story, and literally we could spend a whole podcast on this. The short version, though, is historically, we started with artificial intelligence. By definition, is essentially machines that can perceive their environment and choose actions that maximize the expected likelihood of achieving a goal of some kind. Way back in the day, we just did symbolic AI, so it looks like explicit programming now with some constrained optimization, some other tricks that we're doing, like heuristic tricks of state space search. And so we hit what we call the AI winter as a result of the inflated expectations about what AI would be able to do. Like back in the 50s and 60s, they were saying, oh, this is going to automate every job and no one will have any jobs in another decade. And then none of this stuff ever happened. By the end of the mid-90s, AI systems or machines couldn't even do basic general purpose tasks that even a toddler could solve. So that inflated hype and then subsequent disillusionment when none of this ever happened led to what we called the AI winter, period between the 1970s into the early 2000s, I would say, where funding and research in AI almost completely dried up. So once that term got stigmatized, we'll call it, nobody wanted to be associated with it at all, because you would literally not get funding if you said AI. You literally wouldn't get a job if you said, I'm an AI developer. So everybody used machine learning as a rebranding of AI. Machine learning, more specifically, is a subset of artificial intelligence that focuses on training machines how to learn from data using statistics, essentially. And AI is a much larger category. So then within AI, we have some separation between narrow AI, general AI, and artificial superintelligence, or ASI. So artificial narrow intelligence is essentially machines able to do typically like one task or just a small subset of tasks relatively well, but they can't generalize flexibly to solve other problems. Whereas artificial general intelligence is essentially machines that are capable of flexibly adapting to new situations and generalizing across multiple problems. So you teach it how to play chess, it can also play Go, it can also clean your house and vacuum, it can drive your car. Like literally anything an average human being could do, a general AI by definition should be able to do. And then on the other end, we have artificial superintelligence, which is the idea that if we can create an artificial general intelligence that can program as well as an average software developer, it could, in theory, rewrite its own code and progressively grow more intelligent by rewriting its own source code. And so the idea is that there'd be an intelligence explosion, and we'd end up with something that's smarter than every human being on the planet in a relatively short period of time. But right now, we're beginning to enter this phase of artificial general intelligence where we no longer are using a single definition anymore. We're typically talking about weak artificial general intelligence, or weak AGI, and strong artificial general intelligence. The distinction being, weak AGI just means we can generalize across multiple tasks, whereas strong AGI is typically being used to mean, okay, now this thing can do everything that an average human being can do. I don't know how long it's going to take us to cross this chasm, but we'll probably see varying degrees of general AI in the middle.
Are there any current products that meet the definition of strong general AI?
No, absolutely not.
Okay.
I can't think of anything that comes close yet. In terms of weak artificial general intelligence, though, I would say most people are now beginning to think that like ChatGPT is a form of weak artificial general intelligence within at least one modality. So in terms of language tasks, the last research studies I've seen have essentially shown that the most cutting edge language models, when you give them access to skills and some other augmented language model tricks that we do, essentially have solved pretty much every language task that exists out there, as well as the average human being. There's difficult language problems that domain experts they can solve, but these models can't. But an average person couldn't solve those problems either. So in terms of average person and average language tasks, these machines essentially are at that level right now. Now we're going to create multimodal models, though, where we combine images, audio, video, and text together. And then that's going to be even more generalized because the model of the world that these models build is subject to their inputs and outputs. And so right now, these language models typically just have text as input. So their model of the world is literally described as text. So the world as we could describe it as text. But once we give it images, audio, and video, and touch someday, like robots, it'll essentially be embodied cognition, where it'll be able to experience the world, try things out, see what happens, and then learn from those changes to the state of the environment after it's performed some kind of action.
Okay. And so when you say weak general AI, you mean it can do more than one function, or it exhibits more than one aspect of human intelligence.
And even that definition is a bit blurry. Some people would say that if it can perform multiple tasks outside of its original training task, then it's weak artificial general intelligence. Other people say that it has to generalize more flexibly across tasks that are way outside of its original training set. And so it's hard to even say whether we can call stuff today weak artificial general intelligence or if it's still narrow AI. But this is all semantics, and everyone's definition seems to be different depending upon what their goals are and how they're using AI.
Yeah, seems like the term isn't ever going to get defined. Because I remember when Google Home and the Amazon Echoes were first being put around, I heard a lot of people saying, "Oh yeah, I was talking to the Amazon AI and blah blah blah," and now it's just called Alexa.
Yeah,
just like image recognition. It's just called adaptive cruise control in our car. While I was at this, it's like, how is it slowing down my car? How is it speeding up my car? Because it's productized.
Some of it's to divorce ourselves from the term AI because of stigmas that still exist. In fact, Microsoft avoided the term AI forever because they got burned back in the 1980s, I think, and along with everybody else that got burned by using AI as a marketing buzzword. And so, they have been saying cognitive services for years, ever since they started doing AI in the cloud. And now recently, in the last few years, they've started to refer to some of their more specific services as AI services. But in general, the whole platform is still called cognitive services. Now, Amazon, they refer to it as AWS machine learning or AI services. Google is the same. They will use the term AI. But like Alexa, it's mostly to discriminate it from other types of AI. And in some ways, I think it's to try anthropomorphizing these things. But I don't know if that's a good thing or not. But when your kids start calling it, Alexa, maybe that's a good thing for them in terms of their interactions with the device and for adults as well, too.
Or Bard.
Yeah.
If we're calling Google's Bard.
Yeah. I'm not a huge fan of that name, but it does make more sense in referring to it as Palm 2 or Palm, like one of the internal code names for these things.
Gotcha. Okay, so I want to get into AI ethics, but before we get into that, I want to just talk about, before we can do something safely or do something well ethically, I want to talk about what we can actually do right now. And in preview, Azure has the OpenAI service where you can have the GPT model that they're kind of previewing and whatnot. So for .NET developers, what can they actually do today with this latest generation generative AI?
Interestingly, I just gave a presentation on that topic in Japan last night. And there's so much that it's almost like trying to consume a whole buffet in an hour. So in short, there's a whole variety of things that you can do with AI for tables of data, both synthesis of tables and analysis. So doing table analytics or generating tabular data. We can do the same things with text. So analyzing the text and then synthesizing or generating new text. We can do the same thing with audio. So everything from speech to text or text to speech. And each of these categories I'm glossing over, there's easily dozens of different AI models and tools we can use to solve these problems. And the same thing with images now. There's a whole slew of image detection stuff and image synthesis tools. And then we are getting to the point where we're able to do the same thing with video, though it's not as far along as the other categories yet. But video synthesis is coming soon. And in another year, it's probably going to look almost indistinguishable from a movie you see or a video game you're playing. And then beyond that, we have the ability to take these models, these machine learning models or AI subsystems, and then wire them together into full AI systems. For example, you can take object detection and image classification, which are two different computer vision tools or models. And you can have the object detection find different objects in the image and then send that to an image classifier, the bounding box for each of these pictures. And so then by combining these things, we get image class or object classification. So it's not only doing the detection of it, but it's also doing the classification. And you can imagine being able to mix and match these AI models in so many different ways. It's literally like playing with Legos for AI systems. You just mix and match the bricks together based on what inputs you have and what outputs you need, and then you wire it together with a bit of glue, like code in between. And then the final kind of thing that we can do with these systems right now, which is probably outside of the abilities or the needs of most .NET developers, but we can build cyber physical systems. So these systems where both the software and the hardware are deeply intertwined, and they use a lot of AI and machine learning in order to operate. For example, robot vacuum cleaner, self-driving car. Mm-hmm. The way that these systems work is essentially just like a function, just like all of these other input-output models, but it's much more complex in the middle, and it feeds back into itself. So you're typically running this inference loop, maybe hundreds of times a second, and then making small corrections to the state, the state of the world as input, and then the action decided as output.
Mm-hmm. Okay. So with so many things that can be done, and certainly we see the products that are popping up for video generation and audio generation from text, as well as just, students maybe trying to get term papers done quicker and hope professor didn't know how much they generated. Maybe that's the start of AI ethics, of being honest about what you're using. And then what are some examples right now that you've come across that clearly violate any standard of ethical boundary?
Gotcha. Real quick, before we jump into the ethics, I should probably mention that if people are interested in seeing what you can do with all of these AI tools, I've got an online course that literally covers the entire gamut of them, called the AI Developers Toolkit, and it's available on Pluralsight. But in terms of AI ethics, so the things that I'm seeing that are egregiously just wrong, and there's almost no way to argue against it. I'm seeing some things being done with recommendation engines that I think are definitely on the verge of being careless, if not intentionally bad. A lot of these companies are prioritizing ad revenue and profits at the expense of people's mental health, and that's not a good thing. And not just people's mental health, but social good, democracy, a whole slew of things that are being abused for the sake of pulling people further down these recommendation rabbit holes to generate more clicks. Because controversial topics generate more clicks. Mm-hmm. They keep you on their site consuming content, which means more ad revenue. But that can lead you down rabbit holes to more extreme content, and then conspiratorial thinking, like echo chambers and information bubbles. So that's one of them. Another thing that I'm seeing that is just completely wrong, in my opinion, is, well, actually, I don't know how to say it's completely wrong, but there's a lot of issues around the potential for plagiarism with tools like ChatGPT. So if people are using it to write their essay papers, I think that's wrong. But if you're using it as an interactive Q&A session, say you have to write a paper on Socrates, and you say to the model, pretend that you're Socrates, and I want to have a conversation with you and ask you questions, and then use it interactively to help you understand, well, Socrates' views on X were such and such, or he didn't think so and so. Now, it's a bit tricky because these models oftentimes hallucinate. If they don't know the answer, they will hallucinate. But there are tricks that we can do to minimize hallucinations, and in some cases, almost completely eliminate it, which we can talk about if you're interested. Beyond that, there's a lot of things kind of in the gray areas in terms of things that are bad. For example, we've got lack of privacy with AI. So we're collecting all of this data, which means we may not have control of it anymore. And a lot of it's being used against us in terms of like predicting if we're pregnant or not based on our shopping history, or using public social media data in order to predict private information, which is actually pretty easy for data scientists to do. And then other things with algorithmic bias and discrimination. So problems with these models selectively, I don't want to give intentionality to this, but when they make predictions, they're biased against certain groups of people or certain categories. And then right now there's big issues with lack of trust in AI simply because we haven't made these models transparent enough. So companies that are creating these black box models and then not giving their users any insight into why the decisions were made or how to get recourse if it makes a decision that negatively impacts you. And that's another pretty big issue. Then beyond that, things like misinformation, AI hallucination, and lack of basic AI literacy. I think these are some of the big problems or ways that the AI systems are being abused or misused.
So since so much of the current generation can take questions, and then some people to a different extent rely on the answer to those questions, is it even possible for one of these models to not be biased? And I ask that because my understanding is that these models have data that's passed into them, and the data has to be labeled certain ways. And so someone has to choose what data to put into the model and how to label it. And just the act of choice, isn't that bias? Like if I put into an image model, pick 100% pictures of roosters.
Yep.
But I said, oh, this will identify any chicken, but I only put in roosters, or I only put in, one type of chicken. Well, just because of my choice, haven't I made the model less likely to work for anything that I didn't choose to include?
So it's a really interesting question. And I don't know if it is possible to completely eliminate bias from anything with subjective labeling. Because anytime you have a human being performing the labeling, their existing subjective biases are going to be built into the training data, which is then going to be trained into the model. There are cases where there might not be any bias. For example, if we're doing completely objective things like building a machine learning model that predicts the trajectory of a projectile, like that's using relatively objective data from physics. So you can't say, well, it's biased due to gravity on planet Earth or something. At least I don't think most people would say that. But then anytime you've got anything subjective, we run into those problems. There's a lot of things that we can do to minimize the amount of bias in these models. For example, using very diverse and balanced data sets. So you get a large sample of people involved or a large sample of data involved, and then making sure that you don't have some classes underrepresented, which was one of the problems we had with face recognition systems. They were largely trained on white males, so they got really good at detecting white males, but they were not as good with darker skin, non-gender conforming individuals, and with females. So we have to make sure that we've got balanced data sets in order to get the models to train properly. We can also do other things like we can exclude protected attributes from these models so that we're not, including things like race and gender when we're making either the training or the inferences on these models. But we have to be careful because they can find weakly correlated variables that predict one of these protected classes. For example, we use resume screening algorithms that remove gender when they put the data in, but they will pick up on very subtle things in the wording because in general, women choose slightly different words than men do to describe things. So I can't think of examples off the top of my head. Or they'll say, I was the captain of the volleyball team versus captain of the football team. Or they'll mention a school they went to, which was either an all boys or all girls school. And so these things, it picks up on those and starts to, essentially gender bias the results, which unfortunately, most of these resume screening algorithms are already biased towards male candidates because historically that's what was selected for hiring. So that's a problem. But we also have bias detection tools. So we can use things like the shapely values and LIME. We can do model perturbations or surrogate models in order to try teasing out bias so that we can see, okay, yeah, this model is clearly biased towards a certain group of people. We also have fairness metrics now too, like statistical parity, equal opportunity, and equality odds. There's at least 24 of these fairness metrics that are now being tested and used in these systems. And then last, you have to continuously monitor and then retrain these models because they tend to drift over time and they can get stuck in places where they're making predictions that are now biased over time.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
My next question is, do you think that it's worthwhile to even go for general purpose models that purport to, quote, be ethical versus have models that label and publish what their chosen ethics are? Because it seems like the topic of ethics is all about choice of what you value. And let's say models that are used by people in China would probably intentionally want different values as what they call ethical than people who live in, so let's say, Florida versus New York City versus Brazil.
It is a very timely question because this exact question was debated in a congressional hearing just this last week with like Sam Altman of OpenAI and Gary Marcus, who's some of the experts in the AI space. And so the question is, first, is it technically possible for every group of people to have their own foundational model? Because to train these foundational models requires tremendous amount of GPU power and thus energy. And right now there aren't any good solutions to that. But we also have the ability to take a foundational model and then fine tune it for different types of culture. So we do all of the pre-training on a single model, but then after pre-training, the fine tuning is essentially aligned with specific goals and values and, where we try to eliminate the bias. But once again, even the idea of having, different models for every country creates a whole series of, in the same way that having different rules in every country creates a lot of overhead and tension between sharing information, knowledge, and doing business across different countries. So whether we'll get to that point, I don't know. I have to guess that there are parts of the world that are different enough that they will not allow a model that is not aligned with their values. But we as humans can't even agree on our own values. So I don't know that it's reasonable to assume that AI systems would agree with our values. But I'm also hopeful that with this problem of bias and this problem of values alignment, that we will create AI systems that will essentially self-reflect. And through their own self-reflection, they may come up with values that actually are better than what we have, or less gray or less ambiguous. And that makes me hopeful because I think, a machine that could objectively self-reflect on its experiences, on historical evidence, and all of these things that we can't, compress into our brain in a short period of time, might make it actually a better judge of good versus bad values, morals, and goals than we as subjective human beings are. I don't know, that might be out there in la la land, but it at least makes me hopeful that there might be a long-term solution to this.
As long as you have to train a model, how could the tendencies be any different from how it was chosen to be trained?
So that's the distinction between using supervised learning and then self-supervised learning. Or reinforcement learning as well. So with supervised learning, we're essentially providing the input data and the output labels. So our subjective biases are built right into that. With self-supervised learning, for example, if you just took a bunch of images of pictures of the environment, and you essentially you say, all right, here's your input image. We're going to remove 5 pixels from it. Now predict which pixel should go there. And so as it gets better and better at predicting those missing pixels, it's essentially building an internal model of the world around it. And this model is only biased by what it's seen. So, if you're feeding it a model of streets and highways, I don't think most people would say, oh, it's biased towards country roads versus biased towards interstate highways, in the same way that we think of bias and discrimination. Like in a technical sense, it might be because of the training data that it has. But in those cases, it's not really using human labels. It's essentially just using input data and making predictions about the missing pieces of data. Same thing with large language models. We just feed it a bunch of text, remove a word, and then have it predict what that word should be. Now, everything we do after we pre-train this foundational model is subject to human biases because we use tools like reinforcement learning with human feedback in order to have humans essentially say, okay, that was a good answer. This one's not great. Okay, this one's a really good answer. And this one's, don't ever say that again. And so then we get those subjective biases back into the model. But at some point in time, we may be able to remove the human reinforcement part of this and have self-reinforcing systems where it predicts its own reward function. I don't know exactly what that's going to look like. And it feels like that could be potentially dangerous too, because we're taking our hands even further off of the steering wheel, which could lead to dangerous situations. But like I said, it is possible that that could align better to objective reality and eliminate all of our preconceived biases and our superstitious beliefs or anything that gets us more out of alignment with objective reality and what is actually good values, goals, and objectives.
Gotcha. Okay, so regardless of what may happen 1 decade, 1 century in the future, right now, at least my understanding of the laws of at least the United States, and I'm guessing they're probably similar in other places, where any kind of machine that's being operated, if it malfunctions and harms someone, the operator of the machine tends to be liable in the legal system. And I think this is proved right with the pseudo self-driving cars or adaptive cruise control. If someone kind of isn't paying attention and then the car kills somebody, the person who happened to be sitting in the driver's seat is the one, answering to the court. So in that vein, with the things that we can do today, how should developers of such system, or what should they build into those systems to make sure that they can turn it off or control it and abort something if they see it going in a direction they don't want it to?
Well, I think there is actually a distinction between liability in the case of machines. In some cases, like with the self-driving cars, currently, if you're not paying attention, you're liable. But like in the case of medical devices or certain industrial machines, if that medical device fails due to a technical issue, you're not going to blame the doctor or the nurse. I mean, It was clearly the medical device's failure. So there are cases where I think the manufacturer is liable and not the actual user of the system. But given that, so if we're building AI systems ourselves or training machine learning models, first thing we need to do is make sure that we have at minimum basic AI literacy. We need to understand the pros and cons of different AI systems, understand like what they do, what their capabilities are, what their limitations are. Another thing that I recommend to every one of my clients is we have to have AI ethics reviews at every major milestone of the project. Because as you're building a system, if you're not thinking about, okay, how could this be used for nefarious purposes? Where could this go horribly wrong? What is the cost of failure? And what are our remedies for these failure cases? Until we're thinking about that, or if we don't start thinking about that from the beginning, we end up painting ourselves in a corner where, okay, now it's too late. We built this system and somebody's using it for terrible purposes, and it's failing and causing physical harm or causing financial harm or something like that. So at each phase, you want to just take a moment to reflect and think about, okay, what are the new problems that the system could be creating? How do we rectify those? What is the cost if it fails? Is that acceptable? And if it is acceptable, how do we let users gain recourse in those cases? I think it's really important for software developers to, I don't want to say leading this initiative, but to be pushing for it, because we're the ones building these systems and we're the ones with the insight into this. And managers may not understand the capabilities or limitations of AI systems, or even the long-term potential consequences of the systems we're building. I mean, I myself, with my background, have built systems for clients that were used when we designed it. We had very clear, good objectives for it that solved real-world problems. And years later, I went back and talked to people working on that project, and I'm finding out that they're using it for something I'd never expected it would be used for. And in some cases, it makes me a little uncomfortable the way they're now using the system, either because it's exploitive in some way, it generates profit at the expense of something else, or is just being used in ways that it was not designed to be used, and that inherently could be dangerous.
Yeah. Well, even today with just rules engines, which, used to be called AI in the 80s and 90s, they're just rules engines are being used to reject and approve credit requests more and more by loan originators and banks. And to the extent that at some point a human stops looking at those and just accepts what the computer said. Yeah. Well, now who's to know that the computer didn't just start changing what it used as criteria, and now we're giving some a lot more risky loans out, and that leads to a whole nother set. Like, I could literally talk about the different things that developers should be doing right now to prevent these things, but it leads to a whole nother set of those things. I mean, we really need to have transparency in these systems. We have to understand why they're making the decisions that they are. As I word it, if you can't explain to a judge why your system made the prediction that it did,
or the judge wouldn't explain your answer because the math is too complicated. It is not, it's not transparent. Beyond transparency, we also need explainability. So having the model essentially explain why it made a decision, either using tools like LimeShape or some of these other things, or through natural language explanations, which is actually an area that I've been working on at Johns Hopkins. Having the model tell you why it made the decision that it did in a language that an average user can understand. And there's ways we can make the system do this that are grounded in objective facts based upon the correlation between variables and the output. Other things we need to do, along the lines of explainability and interpretability, is make these systems more trustworthy overall. Essentially, if our users don't trust the system because we haven't provided these things like mechanisms of recourse and explainability, they either won't use the system or it could be used in negative ways. And so we want to make sure that we're in good shape there. And there was one last thing I was going to mention. What was it? Explainability, transparency, trust. Can't remember. I'm sure it was important though.
Privacy?
Yeah, that too. Especially because we can use AI systems to de-anonymize data. So we really want to be used, and just to put it simply, with only 3 attributes. If you give me, what is it? Date of birth, zip code, and your gender, we can de-anonymize data sets with about 87% probability just by joining it with other sets of public data. And so, I mean, you need to be using encryption and you need to be using strong anonymization techniques if your goal is to protect your users' data. And if you can't protect your users' data, I mean, I don't know.
Don't
maybe
gather
you shouldn't. Yeah, don't collect it.
Yeah. More and more, I know this beyond the scope of this is maybe just more of my tendencies. I'm seeing these tools that will automatically generate an email or some type of explanation. And then I'm looking at it and thinking, okay, here's a computer tool that's supposed to generate some text that I, as a human, am then on the hook for reading. Where is my tool to take the text that a computer generated and just shorten it down to an opinion on, should I even pay attention to this or next?
So that does exist. I mean, we can use ChatGPT not just to generate emails, but we can also use it to summarize emails and do things like salient scores. How important is this email relative to every other email you've ever seen in my inbox? So we can definitely build tools to filter this stuff. But before long, it's predicted that a lot of the communication that happens on the internet is just going to be one AI generating an email to get sent to another AI. And they're just going to be talking back and forth to one another. And I don't even know what that world looks like other than a lot of spam maybe or something.
Oh, yeah. Well, we're already catching wind of some of the old books being just automatically redrafted to, take certain concepts out or inject new concepts that weren't there. And now what's true and what's just published lies?
Yeah, I know a guy who has now published 2 books. I think they're both really interesting ideas. One of the books, he essentially took an old book from the 1800s, which was really well respected at the time on some kind of business strategy or something like that. And he asked ChatGPT to rewrite each, like paragraph by paragraph or chapter by chapter for modern like marketing and SEO or something.
Yep.
And the results were actually really good because it used all these tried and true practices, but in a digital SEO context. And then he's selling the book and apparently it's doing well. He also created a second book where it was like a dad and his kids travel back through time and talk to a bunch of historical figures. So once again, he just used ChatGPT. Hey, pretend that you're Socrates. Oh, hey, pretend that you're, Abraham Lincoln. Right. And the kids just have conversations and ask these people, historical people, questions. And now he's selling that book too. But it does lead to the question of, what does the future look like with synthetic media? I mean, if we've got all of this artificially generated content, how do we know what's real and what's not? And there's a bunch of problems with this, but there are also a bunch of potential solutions. I mean, it gets further kind of down the line in terms of like when this is going to happen and when we need to start dealing with this, but it's probably a lot sooner than we think.
Well, we already see the deepfake videos of one politician literally reading a speech from an opposing party politician, and it looks pretty realistic. And you're thinking, are they really advocating for that?
There's tools that we can use, ways we can prevent this stuff from taking over and causing a lot of harm. We do have deepfake detection tools that can detect with a certain statistical accuracy whether something was generated by a machine or not. There's little minor anomalies in the video generation that we can pick up on. Same with text. There's plagiarism detection tools or AI generated text detection tools. But, there's also other things that we might have to do. For example, and these things sound a bit weird, but I literally think these are coming in the next couple of years. So celebrities are probably going to start paying for some kind of third-party verification service. I'm not sure what it's going to be called, but where they literally are able to provide an unmodifiable audit history of everything you were doing, everywhere you were at any moment of any day. So that if someone says, oh, hey, there's this video of this person doing something horrific, they can go back to the service and it will say, on the blockchain, we recorded at this date and this time, this is what was happening. So
so they will fully track their entire lives to protect against liability.
Yeah, which has a bunch of problems. But at the same point in time, if the bigger problem or the bigger cost is huge political scandals, you might be willing to have somebody record your data on your behalf. Maybe you control the data somehow. I don't know how that would work.
Yeah.
But the other thing is, we may have to put everything on the blockchain, literally every piece of digital information, when it was created, when it was modified, any modifications made to it, and anytime it was displayed, so that we can have a complete audit history for every piece of digital media. And if you cannot provide that audit trail, which once again, if it's on the blockchain, it's immutable. You can't make modifications or fake it. Unless you have that complete history, we just don't trust it. And that might be the only solution to prevent the world from just being flooded with artificial media.
Yeah. Yep. So many potentials for good, and then every tool for good is going to be used for bad.
We're just touching the tip of the iceberg here. Like I said, I could talk for hours about all these potential problems and solutions.
Right. But would you, you're getting a master's in AI. I assume that you believe that people should lean into the advances instead of just step back and hope other people don't do anything with them.
Yeah, I have a couple of thoughts. So number one, I think it's important that we have education across the spectrum. Like everybody needs to understand these tools. Otherwise, we're in trouble. Second, I think it's important that we get these tools in the hands of the good actors before the bad actors get their hands on it, so that we can come up with good countermeasures. And I also think it's important that we kind of gradually move into the space. I think Sam Altman's pretty clear about, we want to have people get gradually introduced to these technologies so that they can get acclimated to them, rather than having like Google or Microsoft release this super powerful AI system one day on everyone, and we're just not prepared for it. And then, beyond that, I think we need to adapt to change rather than trying to fight it. And this change is coming whether we like it or not. When you think about the economics behind this, like it's gonna happen. There's just nothing's gonna stop an economic force like this, especially when it's creating literally orders of magnitude increases in productivity. Yeah. And I mean, any other historical revolution we've seen, we have the Luddites that fought against the change and eventually became obsolete. And then we had those that embraced the changes and became the next Rockefellers, Microsofts, and whomever.
Yeah.
But I think it's also very important that we be mindful about all of this too. Like if we are just using this technology mindlessly, it's going to create a lot of problems, not just for us in our own personal lives and our mental health, but for society as well. And so by taking a mindful approach to all of this, we use the technology where it's most beneficial, and then we don't use it where it's not beneficial or potentially causes harm. And we also kind of balance out that conflict between how our brains evolved to survive in an environment with relatively short bursts of stress and then a lot of recovery time. But now we live in a society with technology where we're constantly being triggered by pings on our phone or alerts from emails and stuff like that. And it's just creating a state of chronic stress, which is definitely not good for our mental health. So if we want to be emotionally resilient in the next decade and beyond, I really think that mindfulness, it means it's got to be a critical component to our society, or we're in a lot of trouble.
Yeah, good point. Or even as recent as 100 years ago, the amount of information that we had to digest on a daily basis was a small fraction of what you do if you just start scrolling social media.
Yeah, I believe the numbers are that the amount of data or information that the human species generates every year, it doubles every 18 months. So like in just 2-3 years time, we have created more new information than the entire history of humanity combined. And that rate is not decelerating. It's growing at the exponential pace, or super linear pace at least.
So then it's inevitable that echo chambers are going to happen because people just by necessity have to choose what to pay attention to, right? We're not going to evenly pay attention to a smattering of every possible topic that's out there because it's just not actually possible, right?
Yeah, that's a good point. I don't know my exact thoughts on that because I don't know that I've given that enough thought yet. But what I do know is that it's quite likely in the future, we'll probably have to have services that we either pay for or are provided free that perform information validation for us. In the same way, like I use a news filter so that the only news I get access to on a daily basis is artificial intelligence, machine learning, data science, science and technology, and then just kind of like more tech lifestyle stuff. I don't get exposed to politics. I don't get exposed to social media. Like I literally have a relatively narrow focus on the information that I allow into my life. And it's all vetted by these publishers that I trust.
Yeah.
And so I'm guessing before long, the average person may have some kind of information verification service where they pay the service or it's provided to them that says, okay, based on what you've asked for, these are the most trustworthy sources. Once again, this all gets subjective, but we can actually do measurements to determine how biased or factually incorrect certain organizations are in terms of the news that they're publishing. But it seems completely likely that because of the flood of information, we will have to have AI tools that will choose the news that either we want or that are most objectively true, as much as we can qualify that. I don't know for sure. But I mean, there's all sorts of political issues with this and ideological issues, and I don't know how we resolve those.
Well, just in your method, it comes down to trust. You have some tech aggregators that you've come to trust, but if they start feeding you stuff that doesn't meet your criteria, you're going to write them off because you no longer trust them, right? Whether it's it's a person who's like, oh, my interesting links, but you trust that person. Oh, all the links that he includes, yeah, I like those too. So isn't it all about bias again? We just choose our own bias.
It's interesting how this came right back to the beginning of our conversation with recommendation engines. If you have recommendation engines that are optimizing for profit, then this does become that problem all over again, where it's going to lead us down rabbit holes. But if we have transparency with our algorithms, so we can see what exactly it's recommending us and why, the ability to filter certain keywords of stuff we don't want to have in our news stream, to rank sources based upon, like how we want to prioritize them in terms of our trustworthiness or how much we trust those organizations. And then the ability to fine-tune our own algorithms, like our recommendation engines. Like that's how we prevent all of these harms and we get to the data that we want best. However, that also still creates echo chambers of personal ideology. And so like while I'm a very scientifically oriented individual who now just so happens to think that mindfulness is one of the greatest things ever after a decade of practicing meditation and mindfulness, I would have never gotten exposure to that back in the day because I thought it was woo-woo. I was just like, I don't understand there being any scientific basis to me sitting, and just thinking, about not thinking or whatever for so long, or focusing on meditation. But then, eventually the science did come through and say, yeah, no, this is a real thing. And we've got objective evidence from neuroscience that this is beneficial. So I would have gone a whole decade without seeing any of that scientific research. And that was tremendously beneficial to me. So I don't know. I mean, there's always going to be some, actually, there is probably a solution, and the solution comes from artificial intelligence. And it's the balance between what we call exploration and exploitation in reinforcement learning, where we want to find things that are working and then continue doing those things. That's the exploitation part of it. But we statistically want to always do a little bit of exploration to find things that are outside of the things we know work, because we might find some things that actually work better than what we're already doing. And so in Bayesian statistics, like we literally do this. We, A/B test, and as A is getting progressively better results, we start spending more of our time giving the users A rather than B until we eventually converge, and then we don't ever give B as a possible option anymore. So that could happen with our recommendation engines too.
Well, and that goes to the goals of the user then. You yourself, you've curated what you want to pay attention to. I would say that maybe there's a concept of focus that is a good bias. Someone says, no, I want this stuff, versus believing that they're getting other information and then being deceived because they're being fed information that's not. For instance, if I'm going deep into playing guitar, you know what? I want more about the type of guitar that I play. If I'm a pastor preaching the Bible, I want to go more deep because Sunday's coming up. Versus thinking maybe that we're just seeing a smattering of, hey, what's going on in the quote news, and then just being fed, only certain things.
Well, there's a book called Deep Work. If you get a chance, it's a great book, and it talks very in depth about this exact thing, how our world has become so superficial or surface level or not deep because of the amount of information and even the superficiality of likes on Facebook. Back in the day, it meant something to go say, hey, great job, but now to just bing, thumbs up doesn't really take any effort at all. So it ends up being very shallow kind of interactions with the world around you. And
then YouTube removed the thumbs down. So it's like, what's the balance?
Yeah. Well, they still collect the data from the thumbs down so they can use it. They just don't show it to anybody else to prevent, unlike bombings or something. I don't know what it's called. And I'm sorry, now I got.
Well, since they removed it, does anybody ever go through the effort of clicking it? I don't.
I think they still do because it still changes the recommendation algorithms to, show those videos less and stuff. And anytime I see somebody doing an actual scam, which surprisingly happens more than you'd imagine on YouTube, I'm the first person to report it because I know there's too many people out there that don't understand why Bill Gates and his AI aren't giving out $100 to everybody that shares this email. And so, I feel it's my duty to society to help, people by removing these dangerous scams from their site.
Well, man, we could go on for another hour or so. I think we not only used your current master's program, but also your degree in philosophy. So that was good.
Yeah, it's quite interesting, but I find that my philosophy degree often is more valuable in the work that I do than my computer science degree. And most people would think, oh, that's just crazy. But really, when you understand what the value of a philosophy degree is in terms of your ability to do critical thinking, communicate your ideas effectively, and hold two completely disparate ideas side by side and judge them based on their merit rather than your biases, it is actually a pretty valuable degree.
Yeah. Awesome. Well, Matthew, thanks so much for coming back on the podcast and sharing with us all about AI ethics. I appreciate it.
Awesome. Thank you for having me.
Oh, my pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.